I'm Anil Kumar, and in this video, we'll understand lines and how they can be expressed in different forms of equations. This video is especially for my student Ria, who has shared a beautiful question. So we'll get to that question at the end of the video. It may take about 10 to 15 minutes. Many of my subscribers have been asking me the pens which I used, and therefore these are being displayed here. At present, I'm using these pens, right? At present, I'm using these pens. If you like, you can buy them, okay? Now, let's begin with the main question. We are now talking about lines in different forms. I have already written lines in two different forms. One is called standard form, the other one, slope and y-intercept form. There are many other forms like intercept form, also, which we are not discussing in this video. So we'll consider, or rather concentrate on these two. Standard form is written as ax plus by plus c equals to 0. All the three terms are on the left side, and normally a is positive. So that is kind of important. Normally a is positive, and avoid fractions. So when you write in standard form, you have to take care of this. Keep a, the coefficient of x, as positive. Second, avoid fractions, correct? Now, let us see how to write one form into the other. We have ax plus by plus c equals to 0, and we want to write it as y equals to mx plus b, which is called slope and y-intercept form, mainly because m is the slope and b is y-intercept, right? So let me write down m is slope and b is y-intercept. Both these equations are very helpful in solving application questions, graphing, and many other things. Okay, so let's begin by isolating y from the standard form. The equation is ax plus by plus c equals to 0. So if I have to isolate y, I have to take all these terms to the right side. We can do minus ax minus c. What we are going to get is by equals to minus ax minus c, correct? Now we can divide by b all the terms. So we get y equals to minus a over b, x minus c over b. So these two forms can now be compared, correct? So if you compare these two forms, what do you get? You get m as equals to minus a over b. So that becomes the slope, and the y-intercept b will be equals to minus c over b. Is that okay? So straight away, by comparing, we can find the slope and y-intercept after doing this kind of transformation, right? Now, let me take up an example here. If I write an equation which is, let us say, 2x minus 3y plus 5 equals to 0, and from this equation, if I have to translate in this form and then write what is the slope, m, you can see slope is minus a over b. That means negative of a is 2, negative of 2 over b, which is negative 3. Do you see that? Since here in this given equation, a is equals to 2, b is equals to minus 3, and c is equals to plus 5, correct? So you can find what slope is, and you can find what y-intercept is by writing this as minus c, which is 5, over b, which is minus 3. So the y-intercept is 5 over 3. Is it okay? So you can read from here the slope-intercept form very easily, correct? Now, in the next page, we'll actually see how to do it, transfer or translate one equation to another. So here is an example for you to work with. We have two equations, one in standard form, the other one in slope-intercept form. We will see how to write standard form into slope-intercept form and slope-intercept form into standard form. We have 3x minus 5y plus 4 equals to 0. We can write this as minus 5y equals to, taking 3x to the left side becomes minus 3x and minus 4. Now divide by minus 5. So y equals to minus 3 divided by minus 5x minus 4 over minus 5. So we get y equals to minus minus cancel. So we get 3 over 5x. Here minus minus makes it plus, right? So whenever you multiply even number of negative signs, it always becomes positive. Do you see that? So that becomes slope-intercept form, where slope m is 3 over 5 and the y-intercept b is 4 over 5. Correct? Let's work with the second equation, which is in slope-intercept form. Let's write down in standard form. How do we do that? Now the trick here is, whenever you have fractions, you have to find lowest common denominator, or multiple you can say. Well, between the numbers 3 and 6, the lowest common denominator is 6, correct? Okay. So we can write this equation as y equals to, I'm rewriting the equation, minus 2 over 3x, and then we have plus 5 over 6. Now since the lowest common denominator is 6, we can multiply each term by 6. So we'll multiply this by 6, we'll multiply this by 6, and we'll multiply that term also by 6. The idea is to get rid of fractions. Since in standard form we normally do not see fractions, and therefore this has to be your first step. Now if you look at it, you could simplify 6 divided by 6 is 1, and that gives you 2, right? So now we can rewrite this equation as 6y equals to minus 2 times 2 is 4, minus 4x plus 5. Second step is we have to keep this positive, and therefore I have to take all the terms to left, right? So keeping them in left, we get 6y plus 4x minus 5 equals to 0. In standard form, x term is always first term. So you should write your answer as 4x plus 6y minus 5 equals to 0. So I hope you understand the concept. So what we get here is 4x plus 6y minus 5 equals to 0. Remember, no fractions, right? No fractions. Important thing. Second, a is positive, right? So positive coefficient of x. That is kind of very important to understand. So I hope with this you have understood how we can write one form of the equation into the other form. And now we'll take up the application question where we'll write both the forms. So here is a very interesting question provided by my subscriber. The question is, a farmer wants to build a new enclosure with 2 partitions. He has 60 meters of fencing to build the 3 identical adjacent enclosures. So we'll now work with this example, write equations in different forms, and then see how much information can be extracted from the given question. You can meanwhile pause the video, explore this situation, and work it out. I hope that helps. Now let's explore the situation. Read the question once again. A farmer wants to build a new enclosure with 2 partitions. He has 60 meters of fencing to build the 3 identical adjacent enclosures, right? So this is a very interesting and common question, and it teaches you many concepts. 1. A farmer wants to build a new enclosure. We are assuming that to be rectangular, right? So our assumption here is rectangular. Most of the time it is mentioned. Okay. If not, Let's work on it. This is kind of an open question, right? So wants to build a new enclosure with two partitions. So two partitions in between will be kind of like this. As soon as you do two partitions, do you see three enclosures? Correct? So that is interesting. I could have written with three enclosures, right? Okay. He has 60 meters of fencing to build the three identical adjacent enclosures. So this is very explicit statement. Three identical adjacent enclosures, right? So they are adjacent and they are identical. Okay, now let's work on it. So let's define some variables. We say let length be L and width be W. Okay, so in that case we can say that the length is L. That means the whole length will take this as L, and width is this width is W. Now when I say that he has 60 meters of fencing to build three adjacent, means what? That means the perimeter. That really means that the perimeter is 60 meters, correct? That is sum of all the sides. So sum of all the sides are, there are two lengths, right? So we have L plus L, and as far as widths are concerned, so you have to put partition here also, right? So that becomes the perimeter, sum of all these sides, two lengths and 4 W's. So you can write W plus W plus W plus W equals to 60, and that gives you an equation that 2 length plus 4W equals to 60, correct? Now you'll recall this equation is very similar to the standard form, which is AX plus BY, you can say plus C equals to 0 once I bring 60 to the left side. Do you see that? So this is kind of equation in standard form. Let me rewrite like that. So I could write this as 2L plus 4W minus 60 equals to 0. Is it okay? I can actually simplify this also, dividing each term by 2. So if I divide each term by 2, I get length plus twice width minus 30 equals to 0. So that becomes our equation in standard form. Correct? That becomes our equation in standard form. It links length and width for the given situation. Correct? Now let's try to translate this into slope-intercept form. Let's write this in slope-intercept form. So when I say intercept, y-intercept. Okay. That means we have to isolate any one variable. So let's isolate W. Let's isolate W. Okay. We'll get some fractions, that's fine. So we'll isolate W. So we'll work with L plus 2W minus 30 equals to 0. Since I have to isolate W, I'll keep it here, take all other terms to the right side. So we get 2W equals to minus L plus 30. Dividing by 2, I get W equals to minus half L plus 30 divided by 2. Or we can say W equals to minus half L plus 15, correct? So we have this situation represented in both the forms. Do you see that? So we could write this equation in one form and translate to the other. In the given situation, it was easier to get the standard form first, but there are no restrictions, correct? Now, we have isolated one variable that actually helps to simplify the equations. Now, if you isolate like this, in that case, W is dependent on L. Remember, then W is dependent on L. That means L is independent variable. Now let's explore further the same equation of related width and length. So what we really worked out is two different equations. One was we got slope-intercept form as W equals to minus half L plus 15. And the same equation we also could write as L plus 2W. Let me copy it from there. Minus 30 equals to 0. Correct? So we have these two forms of equation. Now we are going to work with these two forms, and let us see how we can explore. This slope-intercept form, which we have here, it could be used to sketch the graph. So let's sketch the graph of the given function. So if I have to choose what should go into x-axis, what should go into the y-axis. From the equation it is clear that W is dependent on L, and therefore L should be in the x-axis and W should be on the y-axis. Both the units are in meters, right? Both the units are in meters. To sketch a graph, we could use any one of these two equations. This equation could also be written as let me write this as L plus 2W equals to 30. Is it okay? We could write this as L plus 2W equals to 30 also. Okay, anyway. Now, if I take L as 0, then what do I get? I get a value of W as 15, right? I get W as 15. Correct? And if I take W as 0, what do I get for L? So you will see that we could use any of these situations, to plot this graph. The y-intercept is 15. That means when L is 0, we have a point here, which is 15, correct? So at L equals to 0, we have a point here, which is 15. And if W is 0, what is length? For that, this is a good equation to work with. Then length is 30, right? So length is 30. Let's say this is length. Joining these two, we get our function, correct? So joining these two, we get our graph. So let's join them. This line represents possible combinations of length and width. Do you see that? So we get possible combinations of length and width. Let's make a table to explore further. So what we can do now is, this is further exploring the same thing. Since length is our independent variable taken along the x-axis, we could take different values of length. We have already seen that if length is 0, then in that case width is 15, correct? Okay. Now, if I choose those as the values, what is the area? We'll explore what is the area. Area is length times width. So in this case, area is W. Practically, you cannot have length as 0, right? Practically, that is not a possible value, correct? Now let's take different values of length. Let's take the value of length as 10. So if I use 10 as length, let's say 10, then W will be 15 minus 5, using this equation, right? W will be 15 minus half of L. So it is 15 minus 5, which is 10. Is it okay? And 10 times 10 will give me area of 100. Do you see that? Okay. If I take 12 as length, in that case, width will be 15 minus half of 12, right? So this basically could be written as 15 minus half of length. Is it okay? So 15 minus half of length, which is 6, right? So if I take away 6 from 15, I will get 9 here. Multiplying these two, 9 times 2 is 18, and 9 times 1 is 9 plus 1, 108. If I increase the length to 14, I'll get the width as 15 minus 7, which is going to be 8. And 8 times 4 is 32, 3. 8 times 1 is 8, and 1. The area increases, correct? If I take this as 16, in that case it will be 15 minus 8, and I get 7 here. Multiplying 7 by 16, we again get 112. So it seems that great area, so greater area is almost here, if I take a value which is 18, for example, I'll get 15 minus 9, which is 6. And 6 times 18 will give me 108. So you see the values? What we see here is that the area increases for different dimensions, right? Somewhere in between, we might get the maximum area. Do you see that? Somewhere in between, we might get maximum area. So what you can do is, you can try a value 15 here. That will give you 15 minus 7.5. Is it okay? So let's use calculator since decimals are involved. We are not very good at it. So 15 minus 7.5 gives us, in decimals, 7.5. So this is 7.5. What is the area? 7.5 times 15 is the area, which in decimals is 112.5. So somewhere right in the between them, right? So we have these values as, 15 and 30. Right in the center over here, somewhere, if we choose the dimensions, we might get the maximum area. So that dimension gives maximum area, which is 112.5 meters square, right? So Ria, your question was that if farmer has an enclosure of has to enclose with 3 equal partitions with 60-meter fencing, what dimensions will give maximum area? And also, you wanted to explore different kinds of equations. I hope that question is well answered. Go through this video once again. Let me know if the point is clear. Feel free to share your comments and suggestions. Thank you and all the best.